Hello, I'm Andrew, and this is Lesson 2 for Cup of Java Java Libraries. Today we'll be going over the various visual components of a JavaFX program. So let's review the hierarchy. Each stage in JavaFX contains a scene. Each scene in JavaFX contains a graph. A graph is made up of nodes, root nodes, branch nodes, and leaf nodes. We'll go over what these mean later. But nodes are connected with relationships and dependencies. Some nodes may contain other nodes or be connected to other nodes, and nodes themselves have properties and attributes that tell the program how to display each application. So let's start with creating a stage. A stage is its own class and created like any other class. If you've done Java before, you should know how this works. We have stage, capital S, name equals new stage. And we can display the stage by using stage.show. And you can see here, if we create a blank stage and show it, we'll get a blank empty window. You'll also see the various boilerplate we have for setting up a JavaFX program. We have the package HelloFX, and we have import JavaFX application.application, and main extends application, and in our main string args, we have a launch args, which will launch our public void start, which has a stage primary stage. Although primary stage is the default stage, you do not have to use it. It'll only display if you use show. Next, let's talk about customizing a stage. Since stage is the highest order of JavaFX component, customizing the stage customizes the window the stage is in. As you'll see here, we have stage and stage 2, and showing them both creates two separate windows. So first we have set width and set height. These set the dimensions of the screen in pixels. This is the default size and it can be changed. The set max and set min for height and width constrain the size of the window if it's resizable. And set resizable allows the window to be resized or not. So if it's not resizable, then set width and set height will be the size unless changed in the code. The user cannot change it. Set X and set Y set the starting offset of the window in pixels, and this is on your own screen. So it's a bit weird to use since it'll vary between different computers and different monitors. But it can allow you to make windows not start on top of each other or start on top of each other if you want. And set title sets the title of the window. So see, we have the code set up here. We have our set width and set height for the starting. We have set X and Y, so we'll start right around here on the screen. And we have no resizable, and we show. And stage 2, we do have resizable, but we constrain the resizing between 150 and 250. So if we click start, we see we have two different windows. We have fixed and we have variable. So we can go ahead and resize this. You'll see it's very constrained to not a large window. And you'll see that there's this black part. That's because it's not redrawing a background, although we'll get to that later. So you can also see that with fixed, we can't make it full screen, but with variable size, we can make it full screen. But since we've constrained it, it will be as big as it can. It will kind of glitch out because it's supposed to take up the whole screen, but it can't. So we can take that off, and now you'll see that it redrew the entire thing, so it's all black. Within each stage, there's a scene. A scene is its own class, although this one contains the components and layouts that create the JavaFX application. You cannot create a blank scene. A scene must be initialized with a node or layout component. And only one scene is able to be set per stage, and a scene can only be set to one stage. You can set the scene with stage.setScene with the scene. So you can see here, we create a layout, which we'll go over later, and we make a new scene with it, and we set the scene to that new scene. But if you try to make scene 2, which is the blank scene, we can't do that, and it will error out. So next, let's talk about how to set the background of a scene. So we can use the set background, which takes a background object, and the background object takes a background fill object, and we can set a background fill with a color and then two other parameters. These parameters are for edge tapering, which is kind of creating a circular edge, and padding, which is how far in the background will start. And we can apply multiple background fill objects on top of each other. For example, you can see in this one, we create a bunch of background fill objects with different colors and different taperings and paddings, and we stack them all on top of each other on a stage, and we set the stage. So you can see we have this rainbow pattern. And in action, we can set it to be resizable, and now we have these rainbow circles that we can stretch out. You can go up and it creates new ones, and it's kind of laggy because it's creating them all. And you can see it get as big as we want, or we can make it as small as we want. And we can change the parameters with a mount. There's a mount parameter, and we can change the radii of the corners and all that to our liking. But you can see that when stacking it, it can create some really powerful and cool effects. So you might have seen last slide that we have something called an H-box. And an H-box is a type of layout. Layout determines how nodes, which are the visual components of a program, are, well, laid out. So our basic layout is a pane. A pane is an unformatted layout. Whatever you add will just be added in the top left, or it'll just be formatted how each node is said to format. Panes are good if you want to make something very creative and unique, as you won't be limited by any predefined pattern. Hbox and Vbox organize nodes horizontally and vertically respectively. You'll see an example on the right. We make 10 buttons, and with an Hbox, they got laid out horizontally, and a Vbox, they go up to down. Tile pane equally spaces out the grid of all the different nodes. It's good if you want a quick grid and don't really care too much about customizing it. A grid pane is good if you do care about customizing it, because a grid pane is much more adjustable and has much more fine control. A flow pane allows you to control horizontal or vertical layout with wrapping, so again, it's another very convenient one. And a border pane is a bit more complex, but allows you to put nodes in the borders of the screen or in the center, which is good for layouts where you have very fine control over where each item is. So you can see here is we have a make button function that just creates a bunch of buttons with numbered, and we have a bunch of different stages that we're all going to show, labeled 0 through 4. And so we'll start with a pane unformatted, Hbox horizontal, Vbox vertical. Flow pane and tile pane are similar, but they'll both be types of grids. So if we run it, you see we have very different outputs. So our pane is unformatted, so all the buttons get placed on top of each other. We have 29 buttons right on top of each other. Our Hbox lays out just how you expect, horizontally. Our Vbox, just as you expect, vertically. But 3 and 4, they're both grids, but they're both very different grids. So if we go back and look, we see that we had a grid plane, a tile plane, and a flow plane. A tile plane did it equally spaced, while a flow plane just did some wrapping. So if we go back, and we check out 3 and 4, you'll see that our flow plane just kind of let everything wrap and got to about a good size before wrapping, while our tile plane went to much greater distances to make everything even and well spaced. So that's really the big difference between the layouts. Can have nodes added to them on initialization. This happens when you create the layout. This is the simplest way to add to a layout. We just say pane, let's say pane equals new pane, and we put a node in the parentheses. It also allows multiple nodes by using commas, and arrays of nodes, as we saw with the make buttons function. But you can add to layouts after creating them with the getChildren.addNode function. Layout.getChildren gets an array list of the nodes that the layout has, so .add is just an extension of that as the default addition thing for array lists. And it will work for every single type of layout. But it won't always work correctly. For example, grid panes have each node as a spot on a grid, so to properly add to a grid pane, you just have the .add function, which is unique to grid pane. So you can see that you add the node, and then the x value, the y value in terms of the grid, not in pixels, and the width and the height in terms of grid, not pixels. This can get a bit strange because the width and height of the grid can change depending on what components are in it. And x and y are relative to the lowest values of x and y on the grid. So if you add one thing, it will always be at 0, 0 relatively, because there's nothing lower than it. And you can use set hgap and set vgap for grid-based layouts to separate items in the grid. It's in pixels, and H stands for horizontal, V vertical, same with Hbox and Vbox. So you can see with this quick example, we have a button at 5x5, y1, button at x4, y2, button at 3, 3, and a button at 2, 4. So 1 starts at the lowest y, which is 0, which is up top, and that's because there's no y lower than it. And it's about 4 spots from the left. That's because there are 3 other buttons that are to the left of it. And with number 2, it's 1 below and 1 to the left, and it keeps going down. And we have an H gap of 5, so you can see there's a bit of a gap between each button. So now that we've talked more about nodes and layouts, let's revisit the scene graph. Each scene has one scene graph, which is contained in the scene, and not necessarily in the layout, because a layout can contain layouts. So a layout is just part of a scene graph. The root node is typically a layout, but not always, and nodes within a scene are related in a graph. So root nodes have child nodes, and those child nodes can have child nodes, and so on and so forth. Not all nodes can have children. For example, we've been using a lot of buttons, and buttons cannot have children. So those are considered leaf classes or leaf nodes in the graph. And nodes are all relative to their parents, so setting coordinates and setting sizes are often relative to the size of the nodes that come before it. And you can see that when we have a node that has children, that is called a branch node. So nodes, as I just said, come in branch nodes and leaf nodes. Branch nodes typically organize their child nodes, such as drop-down menus, scrolling menus, or separators, and leaf nodes are typically UI components, like buttons, text, labels, pictures, etc. So you can see we have two split panes, and these, we have a button up left, up right, and then a button in split pane 2, down left and down right. And so we organize them vertically with a VBox, and we add them both. And since these are branch nodes, you can see the VBox contains two branches, which is split pane 1, split pane 2, and each of those contains two branches and two leaves, which are the buttons. And so you can see how it's organized. You can see it organized vertically. Then within each vertical thing, the buttons are organized left to right. Let's see a more convoluted example of how this branch and different nodes can play out. So here, it's kind of hard to tell what's going on, but it'll make more sense. So we have the same rainbow background creation from earlier, and we have a tile pane with 30 buttons, and we set the background to the rainbow background. Then we make a horizontal box with 10 buttons, but then we add the tile pane we just made to the H box, and then set the H box background to the rainbow background. Then we set the H box in the new scene, and set the scene to the stage, and show the stage. So I think you can probably guess what's going to happen, although it's a bit crazier than you'd expect. So it starts off and it's kind of hard to tell what's going on. So if we full screen it, we can see that we have two different rainbow patterns. This larger one is the background for the H box, and this tighter one is the background for the tile plane. So you can see that we have the grid pattern from earlier, but it's over to the right a bit because the 10 buttons that we made earlier are behind this. You can't see them because the background is overlaid over it. And so we can just keep doing this, and you'll see that the bounding box of the tile pane we just made is quite large. And so if we didn't have a background, then you wouldn't be able to see this. But it just shows how big default layouts are, so you should be careful when creating backgrounds of nested layouts. Nodes, like layouts and scenes, can also be customized. So the node typically starts at the 0, 0 of the parent's position, so the origin of the parent, unless, of course, the parent is a layout and the layout has a specific place the node should go. So we can set this default position by using set layout X and set layout Y, and it offsets the node in pixels. However, this can be often overridden by whatever layout it's in. For example, an HBox or a VBox won't really care if you set the layout to something very specific, because it's going to do what it's going to do. But something like a pane is just going to let you do whatever, so panes are good for creating fine control like this. And we can set the referred width and height of nodes. Some nodes are resizable, some are less, so this can be very helpful when either dealing with unresizable nodes, where this just sets the width and height, or resizable nodes, so we know when it is on default. And we can set min width, height, and then max width and height for more resizable things, but again, it's going to depend on what layout and what other components are in the application. So you see this quick example with a normal pane. We create a parabola with different buttons that creates an arc. And this can only really be done in panes because other layouts will just override this. But you should try it yourself. Try creating some cool effects or cool art with stuff we've gone over, like backgrounds, different buttons and different layouts, and nested layouts and all different components, and try to see what cool things you can come up with. Next time, we'll be looking at more interactive applications and allowing input via buttons and other stuff.